Good evening, everyone. Welcome to our Zoom webinar on networking and security in Google Cloud. So I'm your host for today's session, and on behalf of NASSCOM FutureSkills Prime and Google Cloud team, I extend a warm welcome to all the learners from APSCHE joining us from different cities. We have not started the session yet, so we are just going to take 2 minutes to give everybody the opportunity to join in and shortly start this session. So please bear with us for 2 minutes.
Sorry, if you are speaking, you're on mute.
No, I'm not. So I'll just begin now. So we have participants joining in, and just a few house announcements before we start the session. One is that as participants, you would notice that there is a Q&A tab that we have as part of the Zoom meeting. So at the end of the webinar, we'll open up the slot to answer the questions. And you're, of course, welcome to post your questions during the session, which we'll take up as we move along. For the benefit of all participants, we'll give it another minute or so to allow more participants to join in, and then we'll do a round of introductions and start the webinar. So just stay tuned, please. All right. Thank you very much, everybody who has joined in. In the interest of time, we'll get started now. We provided 2 minutes extra just to make sure that everybody could get onto the webinar. And during the course of the discussion, I'm sure more and more participants will be joining in. We are currently at about 305 participants in the webinar. So what I would like to do is basically a quick round of introductions for the benefit of everybody who is joined in, and I'll start with myself. My name is Akash Kumar. I'm from NASSCOM team. I manage industry partnerships for FutureSkills Prime, which means that we have partnerships with many technology majors across various technologies in India, and we work towards including training in emerging technologies to FutureSkills Prime platform. That's my role at NASSCOM. We are very proud to bring to you together today our association with the Google Cloud team, and I take this opportunity to introduce both members from the NASSCOM team as well as from the Google Cloud team. We have Raghavendra from the NASSCOM team who helps us coordinate these sessions with APSCHE. We have Sri Shweta, who is managing this particular program from Google Cloud side. She is the adoption program manager for Google Cloud Learning. We have Ashay Singarkar from the Google Cloud team, who is the technical expert and will be available during the session. We also have Gaurav Madan from the Google Cloud team, who is the subject matter expert for the course and for today's session as well. Some more detailed introductions as we go on, but first of all, many thanks for joining us today. We are really proud to bring this webinar to you. The reason you're probably on this webinar is because you've registered yourself for the program, and our intention today is to give you a detailed understanding on the topic networking and security in Google Cloud, which is dedicated to APSCHE Learners. To begin, let's take a moment to go over the agenda for today's webinar. We'll start with an introduction to the topic, followed by the detailed explanation with presentation from Google Cloud's subject matter expert and a Q&A session where you can ask your questions. So let's get started. All the participants should know that you are part of a very large cohort of learners, over 1 million people who are registered on FutureSkills Prime. You are a part of this revolution, and we really hope you can benefit from this program. Your questions are welcome. The reason we are doing this session is that instead of making it only as a self-paced, you also get some insights through the live sessions like these, because our intention is to guide you through this journey. We want to try and do our best to make sure you complete this course within the stipulated time, that is by the end of the August 2023. So you only have a few weeks left to complete the course, and of course, the SSC NASSCOM assessment and the certificate at the end. I also want to quickly point out that we have developed assessment for this course as well, which is live already, and you can see it within your FutureSkills Prime platform account. It gets unlocked once you have finished the entire course of 5 modules. This is a NASSCOM assessment that will be available to you. Here are the quick 4 steps that you can follow to take up the assessment. Being in NASSCOM, because our mission is to try and skill at large scale and bring skilling to as many people as possible. These assessments are priced at a very nominal and a minimal amount of ₹600. So you will, of course, get a course completion certificate from NASSCOM FutureSkills Prime and Google Cloud when you complete this course, but you also have the opportunity to get an assessment certification, which means that you can present this to potential employers, and it's something that you can also help you in career journey. Also, we have some exciting gifts available for the top 200 learners who have passed this SSC NASSCOM assessment. As you can see, there are 3 learners that are displayed on the screens. So these are the 3 learners who were able to complete the training in the fastest way and have already been emailed the information about redeeming their swags from Google Cloud team. So without any further delay, I would like to request the subject matter expert from Google Cloud to take this forward. I will now hand over to Mr. Gaurav Madan from the Google Cloud team. Gaurav is a networking specialist customer engineer at Google Cloud. With over 18 years of experience in the networks domain, Gaurav has dabbled himself in network validation and testing, migrations, design and deployment, network pre-sales, and network technology incubation planning. At Google Cloud, he is working closely with customers in helping them make best use of cloud networking as an enabler for their business growth. Gaurav, over to you.
Hey, thank you. I hope I'm audible to everyone. Sure. So I'll take an opportunity to present my screen.
Yep. I have stopped sharing, so you can go ahead and do that.
Sure. Let me know once you see my screen.
Yes, we are able to see it.
All right, I'll do a full screen. So, all right. First of all, thank you very much for joining on an evening that shows your interest in learning this technology and your commitment towards learning this skill. I appreciate that. I'll be taking next 80 minutes now to run you through with network and network security in Google Cloud. What that means is that I'll break this conversation into four high level buckets. Those four high level buckets are: whenever there is a term like connect to the cloud, how do you approach that problem statement? Second bucket would be, how do you ensure your network is secured in the cloud? The third is, how do you scale your environment in the cloud? And last is, how do you do day in and day out operations in cloud? So these are the four buckets where I'll try to spend some time. Also, these are in order of their preference also. So I'll be spending a lot more time on connectivity because that is where you will face your primary um, challenges. Once you have connected, security next, because you have to secure an environment. Then I'll talk about scaling out the environment, and finally day in and day out operations, how do you take care of that? Now, before I get into the four pieces that I just taught, I'll just try to throw some numbers, right? I hope a lot of you know about it, but it does not harm to repeat that also. Google Cloud as a platform is spread across 37 regions. What is more important are the next three numbers: 187 network edge locations. The network edge locations are those locations where Google's network mingles with any other third party network. So, for example, if you are sitting at your home in a city of India and your home has XYZ company broadband at your home, and when you try to access a workload which is running in GCP, there is a point at which that ISP network gets intermingled with GCP network, and that is called a edge presence point. Some people call it as POP, some people call it as an edge point, but those are roughly 187 across the world. In Indian context, these are Delhi, Mumbai, Chennai, right? CDN locations are those locations where we have put our caching infrastructure. These are more than 100 plus in the world. Last but not the least, if you want to connect your enterprise by directly placing a cable between your enterprise router and GCP, there are points called dedicated interconnect, wherein Google has placed their infrastructure. You are most welcome to bring your fiber all the way till that point and get connected into GCP. So those are also 100 plus in number. So with those numbers in mind, a network by default can be looked at two different categories of network. Um, First is a premium, and the second is the standard. Now, what is premium and how is it different from standard? Although people may use multiple terms for it, but I'll try to keep it very simple. When you are sending a packet from a source to a destination, ideally there are two ways to reach from source to destination. The first way is from source till the destination in Google Cloud. Majority of that source to destination, you go on an open internet. And when you are very near to the destination, you enter into Google's network. That is called standard. Premium is when you're sending a packet from source to network, you enter into Google's network right near to the source, which means that majority of your traffic from source to destination is riding on a premium backbone of Google, which is called premium. Now, let me take an example of it. Let's say your workload in GCP, your VM in GCP is in Mumbai, but somebody is sitting in Germany and he's trying to access the workload in Mumbai. If you are on standard tier, then your traffic from Germany to Mumbai will ride on an open internet. And when the traffic is very near to that workload, that is somewhere in Mumbai, it will enter into Google's network, which means it is on a best effort network for majority of the time. Only when it is very near to the destination, it enters into Google backbone. Versus In premium network, the traffic that is initiated from that user in Germany enters into Google backbone somewhere in Germany itself, because there's a POP in Germany, which means that traffic from that entry point into Google's network in Germany all the way towards Mumbai, the traffic is on Google's dedicated network, which is the most premium network. So that is the high level difference between what is difference between a premium network and a standard network. The users of Google Cloud get these options on their console, which means by default you are subscribed to premium network. But if for whatever reason you want to say that I want to switch to standard, that is an option on the cloud. You can make that switching by yourself by toggling between either a premium or a standard network. Now, why is that important? How am I connecting the dots? As I move forward, as I said, I'll be breaking this whole conversation into 4 parts. How do I connect? How do I secure? How do I scale? And how do I optimize? Let's straight away jump to connect. Now, what do you mean by connect? The most basic construct in any cloud is a concept called VPC, virtual private cloud. Now, VPC, think of it like an isolated network for you. In case of Google Cloud, this network is a global network, which may not be the case with a lot of cloud service providers. Which means that if you log in into your Google console and try to create VPC, let's say you call it VPC1, that VPC1 is stretched all across the world, which means it is stretched across all those 37 regions where Google Cloud is present. This actually means that you can spin your workload anywhere where Google Cloud is present just with the help of one VPC. So please don't carry a notion that I have my workloads in India, I'll create one VPC in India. I'll have a second workload in Singapore, I'll have second VPC in Singapore. I have third in London, I'll create third in London. No, that is not true. You can have just one VPC, and that one VPC is good enough to have your workloads anywhere in the world. And that is why this is called global VPC. Now, why global VPC is important for you? Let's have a visualization here. When you create a VPC, it does not even ask you where is that VPC, because it's a global. It gets stretched out wherever Google Cloud is present. But under a VPC, you create something which is called as subnet. So let's say you create one VPC, VPC1. You create subnet number 1 in US West, and you create subnet number 2 in US East. These subnets are regional entities. Subnet sits beneath the VPC. Subnet sits under the VPC. So you will create VPC. The console will not ask you where is this VPC, but when you create subnet, it will ask you which VPC, which region is this subnet meant for, and that is where you will assign this CIDR range like 10 or 1050XX in this diagram. Why this global VPC is important? Now, if I look at this diagram, if this VPC was not global and I had to connect outside of Google Cloud via VPN, you will have to create 2 VPN gateways, one for this subnet and one for second subnet. However, since our VPC is global, we give you an option to create this VPN tunnel anywhere. I mean, any of these subnets will have a VPN gateway, and this is good enough for all the subnets to go and talk outside of GCP. That gives you a centralized management and a centralized gateway to go out of GCP. Now, let me talk of some more concepts before I go a little deeper. As I said, VPC is a global concept. So this green color VPC is global. Wherever it is in the world, it gets tested out. Let's say there are 2 regions, one in Mumbai, one in Singapore. This is where you go and create a subnet. Subnet is regional. So if you see this subnet, blue color subnet, this is regional. So I create one subnet in Mumbai and I create second subnet in Singapore. When that subnet is created, it stretches across all the zones of that region, which means, let's say if Mumbai has zone A, zone B, zone C, that subnet which you just created is stretched across that zone. That does not restrict you by having only one subnet in one region. You can have as many subnets as you want in a region. So if there is a VPC, you can still create multiple subnets in Mumbai and multiple subnets in Singapore, right? Now, what does that actually mean? Each VPC is a isolated network, which means, let's say you created a VPC 1 and then you created a VPC 2. By default, these VPCs don't talk to each other. These are isolated networks on their own. If you're designing a network and you want to create dev environment separate from prod environment, or you want to keep prod environment different from a staging environment, you should create different VPCs because these are isolated networks. They by default don't talk to each other. Now in this diagram, let's say there is a VPC 1 and there is a VPC 2. In VPC 1, you create a subnet in US East 1, you create a subnet in Asia East 1, and in VPC 2, you just create one subnet which is in US. This VM in VPC 2 by default cannot talk to VM in VPC 1 because these are isolated networks. By default, they will not talk to each other. If you have to make them talk, yes, there are ways we can make them talk, but the point that I want you to please focus on is that these are isolated networks. A VPC is an isolated network, and hence you should think of creating multiple VPCs only when you want isolations in your environment. Now, taking this concept one level ahead, a VPC can be of two types. A standalone VPC, which is a very simple concept, but there is one more version of VPC which is called a shared VPC. Now, what is a standalone VPC? Whatever I have talked till now is a standalone VPC, which means you went ahead, created one VPC. Under that VPC, you had two subnets. Then you created another VPC that also had two subnets. But these two VPCs don't talk to each other. These are isolated networks, and these are called standalone. So in this diagram on the top, this VPC number 1 and VPC number 2, these are standalone VPCs. They don't talk to each other. Now, what is a shared VPC? Shared VPC is a concept where, let's say a developer comes to a network admin and he comes and say, for me to spin up an application, I need 24 IP addresses. Please give me that 24 IP addresses. So what happens in those cases is we create a VPC which is called as a shared VPC, and when a subnet is created under that VPC, we share that subnet to a developer. So if you see on that diagram on the left, on the bottom, I've created two subnets, one in Frankfurt, one in Virginia. I've shared this subnet number 1 to project 1, and I've shared this subnet in Virginia to project number 2. Now, when a developer logs into project 1, he will get a sense that I have a dedicated network in my project. But actually, it's not a network. It is a network which was created by the host project, but it was actually shared with him, so that he don't feel the pain of creating that network to spin up his application. So it is a subnet which was actually shared with somebody, and hence the concept shared VPC. Now, you must be wondering why I said these VPCs are isolated networks, because there can be situations where you want these to talk to each other. So there is VPC number 1, there is VPC number 2. These are isolated networks. What should I do to make them talk to each other? Because there can be situations where, let's say, some part of development workloads need to talk to some part of production workloads also, maybe for testing or maybe for something else, right? Now, there are 3 broad ways to connect cross-project VPCs. This can be within project, this can be across the project also. The first is VPC peering, the second is VPN, and third is called shared VPC. Now, what is VPC peering? Very simple project, very simple concept. VPC peering is a bi-directional concept, which means if two people wants to be friend with each other, person number 1 says to person number 2, hey, I want to be your friend. Person number 2 says to person number 1, I also want to be your friend. They shake hands and they are friends. Same is the concept with VPC peering. If VPC 1 says, I want to be connected to VPC 2, VPC 2 also has to say that I want to talk to VPC 1. If any of these does not pass, then peering does not happen. Peering, that's why I'm saying, is a bidirectional concept. The second thing that you should understand with VPC peering is it is a very binary concept. Now, what is a binary concept? Binary has 0 or a 1. So when these two blue and yellow boxes decided to talk to each other, either they talk completely or they don't talk to each other at all, which means this blue box, when it decided to talk to yellow box, whatever is known to blue, he will tell all of that to yellow. And whatever is known to yellow, he will tell it to blue, so that they maintain exactly the same knowledge base as they have. In technical terms, that means that whatever subnets were visible to blue, it will tell all those subnets to yellow, and whatever subnets were visible to yellow, it will be told to blue. So blue knows what was known to yellow, yellow knows what was known to blue. There is no partial information being shared from one side. That's why I love to take this example. It's a proper friendship relationship. Whatever I know, I'll tell to my friend, and with the belief that whatever is known to my friend, he or she will tell to me. That's VPC peering for you. Now, what is a VPN and why is it used? Now, a lot of you who come from networking background, VPN is a mechanism to connect something with other over an open internet. Let's say a lot of you do a VPN from your laptop to a data center, or you do a VPN from one machine in India to log in into a different web server, which is somewhere outside of India. But behind the scene, what happens is VPN makes a tunnel between one end to a second end, and that tunnel is over an internet. Now, what is has to do with Google Cloud? If I have to connect two environments, which is VPC number 1 and VPC number 2, and for whatever reason that peering concept that I introduced to you is not an option for you, in that case, there is another option which is called VPN. Now, by VPN, I mean we will create something called as VPN gateway in one VPC, and we'll create a VPN gateway in second VPC, and we'll just connect them. Now, with this word IPsec, you might be thinking that this traffic goes over internet, which is not true. Now, if you are connecting two ends of Google Cloud, because Google Cloud have their own network backbone, this traffic generally do not go outside of Google backbone. It stays within Google backbone, but the underlying mechanism that is used to connect these two endpoints is an IPsec tunnel. Please keep in mind that while VPC peering, which is the concept that I introduced before this slide, to draw a rough image in your diagram, in your mind, that's an limitless concept that has no throughput limitations. But if you connect something using a VPN, there is a limitation on the throughput. For example, in this case that I'm showing on the screen, one tunnel can carry 3 GB per second only. So if you have, let's say, a producer and a consumer wants to consume a service from producer which is under 3 GB per second, this is a great way to connect. But if your environment scales out and you go beyond 3 Gbps, you would either have to create multiple tunnels or switch back to your peering. Last concept in this connectivity is a shared VPC. Now, shared VPC is again the concept that I introduced a few slides back. You have a concept called a host project and a service project. In host project, your network admin creates multiple subnets and he shares those subnets with these service VPCs. So in this, let's say this 10.x.x.x, this subnet was shared with apps project. And this subnet 192.168 was shared with management project. So when somebody logs in into management project, he or she can spin a VM without even bothering that is there a network or not, because network was already shared with him by somebody else. So the responsibility of person logging into a management project is just to go ahead and create a VM. Please don't even bother about network, because network is already created by someone else and shared with them. So that way, if apps needs to talk to this host project or if DB needs to talk to this host project, or app needs to talk to DB, they are they're already connected because they're a part of the same VPC. It is just that it was shared. Um, now, taking one step further from the connectivity that I said, whatever connectivity mechanisms that I discussed till now were the ways to connect within Google Cloud. But we don't live in an idealistic world. There are environments which are outside of Google Cloud also, which means there can be your workloads which are in on-prem, there can be workloads which are sitting in AWS, Azure. Either you are in a hybrid cloud or in a multi-cloud environment, right? The workload sitting in GCP cannot be in isolation. It can never be the case that if you spin up an application in GCP, that will not talk to outside world, right? And hence the second concept, which is hybrid connectivity, becomes even more important, which means that a Google Cloud VM is either talking to an on-prem or are talking to other clouds. Now, again, making this step by step, how many ways do you have to connect? There are primarily three ways, but third you will never, you will rarely see in environment. Think of it like two ways to connect. First is VPN. So let's say you want to connect your on-premise data center with GCP, just create VPN tunnel between two. Your on-premise firewall, which is capable of running VPN, can directly make a VPN tunnel to a VPN gateway in GCP and they get connected. The only thing that I want to focus over here is there is a limitation on the bandwidth. You cannot go beyond a certain GB per second, and the traffic is on open internet. So there is no guarantee of how fast that traffic movement would be, because eventually the traffic is going on an open internet, which is not a committed transport. The second type of connectivity is called as an interconnect. Now, interconnect, think of it like a private network. If you want to connect your data center to GCP, you can either explore one of the two options, which is called a partner interconnect or a dedicated interconnect, and I'll introduce you in the coming slides. But the gist of it is either you lay a physical fiber cable between your data center and the entry point of Google, if you can do that, or you take help of a service provider in middle who can connect your data center to GCP. The first option, wherein you take the responsibility of laying a fiber all the way from your data center to GCP, is called dedicated interconnect. And Google has published the list of locations where we have placed our router and you can bring your cable all the way to that point. That is called dedicated interconnect locations. But if you're taking help of one of the service provider to connect, that is called partner interconnect. And those partners are partners like Airtel, Vodafone, Sifi, Tata Communications in India. So you approach them and they kind of say that we'll take the responsibility of connecting your data center to another stuff, which is lying in GCP, right? Now, if you have to visualize this interconnect, dedicated interconnect, as I said, you take the responsibility, you as in a customer, you take the responsibility of bringing a fiber all the way from your data center to GCP's location. And the offering is 10 GB and up. Because our ports are 10 GB and up, so we can either give you 10 GB speed or a 20 GB speed or a 30 GB speed. But if you say I want 5 GB, no, there is no option, because our offering starts from 10 GB per second. However, on the partner interconnect, you give the responsibility to a partner. You go to a telecom provider, let's say Tata Communications, and you say, dear Tata Communication, I want my data center, which is in so and so location, to be connected to Google Cloud, and it is partner's responsibility to do whatever is needed to connect from this to that. And of course, they charge you for that, but it is the partner's responsibility, right? And that offering can be a subset of 10 GB. So you can go and talk to Tata Communication and say, I need only 5 Gbps, or I just need 2.5 Gbps, right? It can even mean Mbps if you don't even want that, but that is the negotiation that you as a customer do with the telecom provider. Now, there's a third concept which is not listed in this slide in detail, but that is called cross-cloud interconnect. What is cross-cloud interconnect? Till now, I have talked of the ways only to connect your data center to GCP. But let's say you don't have any data center, everything is in cloud. Some of the workloads are in AWS, some of them are in Azure, and some of them are in GCP. Now, how do you want them to be connected in a private fashion? To enable that, there is an offering which is called CrossCloud Interconnect. CrossCloud Interconnect should only be considered when it is a multi-cloud environment. How does it work? If you don't have cross-cloud interconnect, you take the responsibility, you as in the customer take the responsibility, wherein one side it is Google, other side it is an alternate cloud. You put your router and you connect them. And it's a very costly, like you'll bring your router, you'll identify a facility where Google is also present and another partner is also present, and you connect them. But with this cross-cloud interconnect, you don't need to kind of own any infrastructure. Google's take the responsibility of laying a direct fiber cable between ourselves and AWS or Azure. But again, please remember the entry point for this offering is 10 Gbps, because neither Azure, AWS nor us have any port less than 10 Gbps. So if you want direct fiber connectivity between, let's say, AWS and GCP, you will come to us. You will say, I want CCI offering, which is cross-cloud interconnect. We will say, fair, we are giving you a 10 GB port. Please go to AWS and ask for another 10 GB port. Once that port is available, Google will directly put a cable between themselves and ourselves, and we will own the SLA for these cables so that you get connected from our environment to their environment. Then obviously the VM to VM communication or VM to database communications, etc., are taken place. That brings me to end of first section. I'll take a 30-second pause to see if there are questions. All right, I don't see a lot of
Yes,
questions.
Gaurav, before you begin the next section, I think we have a question from Kancharla. She wants to know, how can we identify theft to be prevented?
Okay, so that is a topic that I'm gonna cover in security, which is the second section. But as of now, I've covered only connectivity at the moment.
Okay.
Yeah.
All right. Let me see. Okay, there's another question from Ravi Sai Chaudhary. Hi, sir. If I connect from my instance in AWS Cloud to Google Cloud, is it possible? If yes, can tell me more about it.
Sure. So as I just said, there are multiple ways to connect your other cloud to GCP cloud. The simplest is VPN. So you spin up a VPN service in AWS, you spin up a VPN service in GCP, and just connect them. It hardly takes 2 to 5 minutes to kind of just bring the offering, and that can be up in no time. But if that does not meet your purpose, either because of throughput or because of security concerns, then obviously we can go ahead with other methods like cross-cloud interconnect, which I just introduced before this slide.
All right, thank you for that. So there are a couple of questions I think that Ashay would be more likely to answer. So one of the questions is, I completed 3 batches within 3 months, and I didn't get any extra 400 credits. Presently, I completed all 5 badges. What I do with the remaining credits? They are expiring within 10 days. Maybe Ashay, you can guide the learner. Manikanta is the learner.
Yes, I was about to answer this question on chat.
Okay.
So you can write this issue to support@quicklab.com, and I'll take it from there. I'll have to individually check the email IDs and everything, and I'll
Okay. So Manikanta, I'll just answer you with the email ID to which you have to write, and then Google Cloud support team will take it up. Thank you for that, Asha. Thank you, Gaurav. You may proceed with the next section.
All right. So now my second topic is network security. Network security and what I'm going to cover in second section is, so security is a broader topic, right? And I can't do justice with that in a 30-minute kind of a time, but I'll keep it simple only to the network security aspect to it. Now with network security aspect of it, what are the primary things that you are covering? So the primary thing that should be your focus uh, is there a public access that is a sub component of my overall ecosystem, which means can I define what FQDN can I talk to, or can I define let's say a threat intelligence into my network? What are these terms I'll introduce? How do I do a traffic inspection, either a web traffic or an SSL? Is there a way that I can intercept the traffic which is coming in or going out? And is there an aspect of AIML that I can bring onto my network, right? Now, with these questions in your mind, the common capabilities that you should be wondering are um, the end-to-end outcomes, which means between one source to destination, are you able to achieve the required outcome in terms of security? Like this type of traffic is allowed, that type of traffic is blocked. Are there enough insights, which means if somehow something is not working or if something is dropped intentionally or unintentionally, are there enough insights for you to find out why that traffic is blocked? Is this because of your configuration or did somebody misconfigured it? Is it way to automate this entire concept? That is, whatever rules, policies you are writing, is it possible to automate that? And finally, once you have detected something, how fast can you respond to it? With these in mind, let me put a very simple architecture in mind, and this is the genesis of whatever I'm going to talk in next few minutes, right? Now, when you have your application in any cloud like GCP, think of it as the bottom figure. Like I have a load balancer, I have VMs running, I have Kubernetes running, whatever, right? Now these have to be accessed from internet. This type of traffic is called north-south traffic. North is internet, south is where your workloads are. Now, when you want to inspect this north-south traffic, there are multiple ways, there are multiple places where this traffic should be inspected, and there are multiple ways where this traffic should ideally be either dropped or allowed, right? Now, that first place where this traffic should ideally be inspected is called as the edge of the network. Now, what is the edge of the network? When I started my presentation, I said there are various edge point of presence where any other network meets the Google network. That is the first place where your traffic should be inspected. Which means, let's say, same example, if your traffic is coming from Germany to your workload in Mumbai, the first place where this traffic should be inspected is when that traffic leaves a third-party network and enters into Google Cloud Network. And that is called edge security. All the things which either has to pertain to DDoS attack or has to pertain with web application firewalling generally takes place at the edge of the network. Now, there are a lot of situations where either customers or students or professionals in this industry, they are used to one kind of firewall. Let's say they believe that I have my hands dirty on Palo Alto and that is what I want to stick with. I want to bring the same experience in Google Cloud. Can you enable me? Yes. That is called third-party firewalls in GCP, which means we give you the compute, you bring that third-party firewall software and run it on our compute. That is called self-managed third-party firewall, which means you buy a license of Palo Alto or Cisco or Checkpoint or Fortinet, whatever firewall you are comfortable with, you bring that license or buy the license from Google Marketplace and spin that application of firewall on a VM. That is called self-managed, which means customer takes the responsibility of managing that firewall software as well as take the responsibility of managing that compute on which that firewall is running. If you tend to do that, that is your second layer of protection. Now, your third layer of protection is something called as native firewall. Whenever you create that VPC, which I introduced in section number 1, each VPC has something called as cloud firewall. This cloud firewall is fully managed by GCP and is a native solution, which means your responsibility as a customer is just to write rules. No licenses, no scaling in, no scaling out. Everything is responsibility of Google. It's a managed service for you. If you want to say that any traffic coming from internet should be blocked at port 80 and should be allowed at port 443, you have to just, your responsibility is to write that rule in the firewall. Rest everything is taken care of. That rules goes and apply to one VM or second VM or 100 VMs or 1000 VMs is the responsibility of Google Cloud. You don't have to scale your environment for that because it's a managed service. So we have talked of 3 layers till now, and we have talked of traffic which is called north-south traffic. Now let's talk of traffic which is called east-west. Now what is east-west? East-west is a traffic that remains within GCP. So which means, let's say if there is a web VPC that wants to talk to database VPC, you want to define a rule that when web talks to database, only TCP port number 1234 is allowed. For that, you have 2 options. Either you write the rules on these cloud firewalls only. Simplest and easiest way of doing it. Or if you're bringing a third-party firewall, you can actually do a hairpinning on those third-party firewalls saying that when traffic comes from web and it is going to DB, port 1234 is allowed. In a hybrid cloud environment, when your GCP workloads is talking to on-prem, you can do almost the same thing, which means this third-party firewall can take the responsibility of hairpinning the traffic towards on-prem, or you can do a VPN protection, etc. if you are choosing VPN. Now, a lot of time you will find the situation where your VMs don't have public IP address, and that is a good design also. By not giving public IP address, you are protecting your VMs from directly being accessible from anybody and everybody on the internet. When that is the case, you spin up something called as CloudNet. CloudNet is a managed service of Google, which allows you to connect VMs without public IP address to go and talk to any machine on internet. Let's say you have a VM which does not have a public IP address. It's a Windows VM. It wants to do a patch upgrade. It wants to download a new safe security patch from Microsoft.com, right? For that to happen, it needs to go and talk to a machine on internet, right? Because it does not have a public IP address, it cannot go and talk to internet. If you want to enable that kind of flow, you spin up something called as CloudNet. CloudNet enables public internet communications of those machines which does not have public IP address. And this is also a managed offering. You don't care about, you as a customer don't care about scaling it up, scaling it down. It's a managed offering. Last but not the least, if you want to inspect what traffic is coming in and what traffic is going out, you finally rely on something called as packet mirroring. So you mirror the packet, inspect what is going on, and then take a judicious call that was it a legitimate traffic or was it not a legitimate traffic. This is called mirroring, and that is available for you to consume. Now, having said that, I can't, as I said, I can't do a justice with all the 6 concepts that I introduced in last slide. I'll take the most important concept, which is called cloud firewall. Now, cloud firewall, I said, it is the most simple managed service, which is for you to consume, right? And with that in mind, imagine this picture in your mind. When you're writing a cloud firewall, it is a fully distributed and a cloud native firewall, which means whatever rules you write, it actually goes and get executed near your workload. So you can write your rules which identify micro segmentation also, which means that you want to say that my red VM should have this type of rules and my green VM should have this type of rules. You actually can go and apply a tag at your VM, and you can write your rules saying that red VM should not talk to green VM, right? So please start developing those images in your mind wherein you tag your VMs as production VMs and other VMs as development VMs. Now you want production machine should not talk to a development machine. So you will write a firewall rule which says source is equal to tag production, destination is equal to tag development, action deny. So if you start imagining the picture like this, you will come up with a native firewall solution in your mind, and that is you have to write only one step for it, which is cloud native, just distributed. People more concerned about price, this is free of cost. So the basic security is free and should be done without any second thought in the mind. Now this firewalling, if I have to just put some more color to it, these are offered as 2 tiers. It is called essential tier and a standard tier. With essential tier, you get almost everything at layer 3, layer 4, which means you can say this IP talk to that IP, or this IP can talk to that IP over port 80. So you are just saying IP and port, and that is the only thing that you are doing. But if you want to go beyond layer 3, layer 4, that is where the standard tier comes into picture. For example, you want to write a rule which says your production machine should only be accessible from India. Now that is beyond layer 3, layer 4. You are defining a geolocation object which says if source lies in India, then only my red VM should be accessible. Right? Or you want to say that every country in the world is allowed to access my VM except one particular country. Now, when you do those kind of environment, that is called geolocation, allow a geolocation block. There is a concept called as threat intelligence, which is a very powerful concept in network security, which just says that you as a customer don't maintain a list of, let's say, malicious IPs. If you want to write a rule which says any malicious IP in this world should not be allowed to access my application, the list of malicious IPs is not available to you, right? And that list grows every day and now, right? So you rely on Google Cloud Threat Intelligence, and with that, you just tell to Google Cloud Threat Intelligence, whatever is your database of blacklisted IPs, please compile that list and put it in Google Cloud Firewall. And with that, I will just write a rule saying if source is equal to bad IP, block. That is called threat intelligence. And if you want to do an FQDN base, for example, the example that I took, the VM should only be allowed to go and talk to www.google.com and www.microsoft.com. No other FQDN is allowed to be accessible from my VM, right? With that, these kind of requirements, you are going beyond layer 3 and layer 4, and hence you want to subscribe to a standard tier of Google Cloud Firewall. Now, once you've decided what tier do you want, there are some optional add-ons that you might add to your kitty, and these gives you enough insights like what is happening, which firewall rule blocked my traffic, which firewall rule dropped my traffic. Those are kind of add-ons that you can add on to your security architecture. I'll take a very small pause to kind of see if there are questions on security. I did not cover all of those 6 elements, but the most important element is Cloud Firewall, which I believe is genesis of anything which can be termed under foundation security in Google Cloud. I've covered that. Are there questions?
So, Gaurav, I think there is just one question that I can see. Kancharla wants to know if it is legal to use VPN in India.
So VPN as a concept is an open technology, and yes, it is legal to use VPN, but VPN is a technology which is either an open source or you can be brought it with any firewall. Also, it is legitimate technology. But if you meant to ask that there are some websites which are not available in India, and can I VPN and access that? That is decided by the government and the telecom authorities in India, that there are some websites which are blocked in India. Can I access it using VPN? I think that is a subject which is outside of things that we are discussing right now. But as a technology, VPN is an open technology. Even Google Cloud supports it, and yes, that is something that you can configure. VPN is an age-old technology which is supported.
Okay. Also, we have a couple of hands raised, so I will just try and allow them to speak so that they can ask their questions. So the first one we have is Bimi Reddy China. Can you please unmute yourself and speak up your question, the doubt that you have?
Hello, sir. Good evening, sir.
Yes.
Yes, good evening.
Sir, not out, sir. Clear, sir. Thank you, sir.
Okay. Then we have a question from Mandapati. I'll allow you to talk. Can you please unmute and ask your query?
Hello? Oh, good evening.
Yeah, you're audible, Mandapati. Go ahead and ask your question.
No doubt, sir.
Sorry?
I think I said no doubt.
No doubt. Okay. All right. I think we can go ahead and continue with the session.
Sure. Now I've covered two sections, connectivity and security. This next section that I want to cover is how do you scale your applications, right? Today you have one VM, tomorrow you may have 10 VM, after that you may have hundreds of VM running in Google Cloud. How do you keep up with that scale, and what are the methods to kind of do it? Whenever you talk of expanding your reach inside a Google Cloud, the very first concept that comes is called as load balancer. Now, this is a concept which needs some attention from all of you, because when you log in into Google Cloud and either you attempt to do labs around it or you try to do, is there a question?
Raghavendra, request you to kindly mute.
Okay, I'll continue. So whenever you
Okay, Gaurav, you may continue.
Sure. Whenever you log in into Google Cloud, load balancing page is something which will give you a lot of options and becomes sometimes become overwhelming when you see those many options and you feel like which is the option that I should be choosing, which is what I should be ignoring, etc., etc. Hence, this small section that I'm covering unearths um, that puzzle, which load balancing option is good for you. Now, if you see these three options, the major buckets are application load balancer, network load balancer of type TCP, and network load balancer of type UDP. So the very first question that you need to ask yourself is your application an HTTP/HTTPS based, or is your application listening at TCP or UDP? If the answer to that question is that your application is a HTTP based application, the left hand side of the diagram, which is application load balancer, is your friend. And there are multiple options under HTTPS, which I'm going to talk, but at a broad level, you will look at something which is called application load balancer. If you're working on, let's say, a gaming application, which typically listens at UDP port, then your answer would be that you need a network load balancer of type UDP. If your application is listening at any other TCP port, which is non-HTTP, HTTPS, you need something which is called as TCP load balancer, and that TCP load balancer can be a pass-through or a proxy. Now, once you've taken a very broad decision of one of these three load balancers, now these three load balancers also comes in multiple flavors, and I'll try to solve this puzzle in a very simple manner for you. So you have already taken a decision on either an HTTPS load balancer or a TCP UDP load balancer. Now, these load balancers are further divided into two parts. Are these external load balancers or are these internal load balancers? What is the difference? If your application gets traffic from internet, now you need an external load balancer, which means people from internet, they want to access an application behind a load balancer. You need an external HTTPS load balancer. If your application is within GCP, which means a database wants to, bad example, let's say your application wants to go and talk to web layer, and that web layer is behind a load balancer. Now, this is internal to GCP communication, for which you need an internal HTTPS load balancer. Now, let me take a different example. Let's say your application was not HTTPS. Your application was a TCP or a UDP application. You need to ask one additional question to yourself. Do you need a proxy load balancer or do you need a pass-through load balancer? Now, what is a proxy and what is a pass-through? A proxy load balancer is a load balancer which terminates the client session and then starts a new session towards the workload. Which means, let's say there is a client which wants to access your application. The client sends a connection to this load balancer. Load balancer terminates the client session, and then it starts a brand new session from itself to workload. That is called proxy load balancer. If the load balancer does not terminate the session and directly sends the client session all the way towards the workload, that is called pass-through load balancer. So the second question that you ask yourself is it a pass-through or a proxy requirement? If the answer is that it's a pass-through, then please ask, is it an external application or an internal application? That will give you the load balancer that you want. If the answer is that it's a proxy load balancer, and a proxy load balancer can again be a global, it can be an external or an internal. Amongst external also, it can be either a global or a regional. Now, those are a lot of options. In this small diagram that I'm projecting on the screen, there are 8 different options written. So an application load balancer can be of 3 types. A network load balancer of type proxy can be of 3 types. Now a TCP load balancer of pass-through can be of 2 types. So these are 8 types of load balancers. Now I don't expect you that if you are a beginner or if you are slowly getting on to GCP to remember everything that I'm just talked about. So I'm giving you a decision tree. Now what is the decision tree all about? It is almost the same thing that I've talked in last 5 to 10 minutes. First thing is, please ask yourself, what is your application type? Is it HTTP, HTTPS, or is it TCP, UDP? If it is HTTP, HTTPS, you need an application load balancer. If it is a TCP, UDP, you need a network load balancer. That is first problem you have solved, which is this blue color. Which type of load balancer? Let's say your answer is, my application is HTTP, HTTPS. Next question you ask is it an external application? Is it an internal application? Let's say the answer is internal. Now, internal HTTPS load balancer can only be regional. So your answer is, please go and deploy a regional internal application load balancer. You will get an option in GCP console to spin this, to configure this, right? But let's say if you ask the question, it is an HTTP, HTTPS load balancer, it is an external application. The next question you ask is this application accessible throughout the world, or is it only one region that the users will come from? Let's say the answer is the users will only come from Mumbai or India. Then probably you are good to go with the regional concept. The global is something that gets spun up everywhere. The users can be anywhere and the workloads can be anywhere. So basically you will choose those kind of load balancers. This diagram I have taken from Google's documentation. So if you go and search for how to choose a load balancer on GCP, you will get this diagram. And that should be your friend whenever you are configuring or choosing a load balancer type. Because as I said, these number of options are huge. These are 8 load balancers, and hence you might get confused and you might end up spinning a wrong load balancer and your application may not work. So please go ahead and do some study on documentation. If you cannot study, please have this documentation handy with you when you are spinning up this. Now, some aspects about these load balancers. First is, as I said, HTTPS external load balancer. It works on something called as anycast IP address. So you have your users in US, you have your users in Singapore, you have your users in New York. All of them will get a common IP address. With this common IP address, your workloads can be anywhere. If a user comes from Singapore, this load balancer will send it to the nearest VM, which is in Singapore. If the user comes from New York, this will take the responsibility and give it to US East VM. And hence it is multi-regional load balancing. Your users are also coming from various parts of the world, but your application is also spun up in multiple regions of Google Cloud. And that is why you say that this is a multi-regional load balancing also. And this layer can be an HTTP, HTTPS layer. So if you are doing an HTTPS, this is where you get your HTTPS certificate loaded up. Versus if you do, let's say, a TCP UDP load balancing. Now, a TCP UDP load balancing is more regional in nature. I'm talking of pass-through right now. So let's say you say I'm doing a pass-through layer 4. There is a user in California, there is a user in New York, and there's a user in Singapore. So you will end up creating regional load balancers, pass-through. When you do regional, that means you have created 3 load balancer, one for Singapore, one for New York, one for California, and they will do the traffic redirection only to that region. So Singapore guy coming into Singapore load balancer and sending the traffic to Singapore region. A New York guy coming into New York load balancer and sending the traffic to, let's say, Europe. This is what you decide. And that's why I say it is a pass-through, but more regional concept. What does this regional load balancer does not provide? Because it's a layer 4, you cannot route the traffic based on layer 7. You can't say that if the traffic comes with www.example.com/path1 sent to this VM, and when it comes to www.example.com/path2 sent to second VM. You can't do that because that's a layer 7 concept. The load balancer I talked is a layer 4. And you can't do a TLS offload also because it's a layer 4. Now, I'll jump this layer 4 internal load balancing because this is almost the same. In scaling, the second concept that I want you to be introduced is the concept of CDN, which is a content delivery network. Now, I'm sure a lot of you, every one of you would have experienced YouTube, right? When you play a hit song on a YouTube, where does that song get played from? Let's say a 1 million people is listening to a very common song these days. Do you believe that all those requests go all the way to a server in Google Cloud, which is a YouTube server, and that song is being played from that location? The answer is no. YouTube has a layer called caching layer where that popular content is being loaded very near to you. And that is why whenever you play a button, almost in a millisecond time, you start that song, right? Now that concept is called caching. Google Cloud offers you 2 types of CDN. One is called Cloud CDN and it's called Media CDN. Cloud CDN is more suitable for website delivery, and Media CDN is more suitable for media delivery, which is audio and video, right? Now, let's say all of you are watching, some of you who are cricket fans and who log in and see, let's say, a very popular cricket match being telecasted on a TV. You see sometimes written on top right corner of the screen that 1 crore people are watching this match. Now, do you believe that 1 crore people are directly watching that match from the server? The answer is no. That match is being broadcasted using a caching network, which means it is that that content is uh, on the caching servers, and you as a user get that match delivered via the caching server near to you. Because there is no server which can scale up to crores and crores of requests coming to it in a millisecond or a second time, right? Every ball that is bowled and a crore people watching it, the crore HTTPS request or web request cannot go and land on a server and gets delivered, right? The servers may crash. That's where the caching networks comes into picture, right? Now, the CDN primarily serves 3 use cases. One is the whole site delivery. Think of your favorite shopping site. Thousands of people log in. Let's say there is a year-end sale, or there's a Diwali sale, or there is a 15th August sale coming up. Thousands of people log in and place their orders. Now, all those users the session of those users directly don't go to the web server. There's a caching layer where the content is served, right? That is called whole site delivery. And then there is audio video. All
Gaurav, I
Gaurav,
think we missed you for a few seconds.
yes,
all right. Where where did you lost me?
I think just a couple of seconds back.
Okay, sure.
And I think we can't see your screen yet.
Yeah, even the screen sharing is gone now.
Yeah.
So let me share my screen again. Is my screen visible now?
Yes, now it is.
Yes, up and running.
Sure. So I'm just taking 3 examples of CDN. If you don't have any CDN, all the requests will go to your server and your server will serve the content. So if there are, the example that I took, if there are thousands of requests, all 1,000 requests will go to your server. Your server should be capable enough of serving all those requests. Let's say you put Cloud CDN, which is the website delivery. All those requests go till Google's POP cache, and Google's POP cache will have enough capacity to serve the content. If that POP cache does not have any content, then only the request will go to origin and will be served out. So let's say there are 1,000 requests coming in. If this POP cache is serving with 95% of hit ratio, 95% of that 1,000 requests will be served directly from Google's cache. Only 5% will go and hit your server. So your server will now get, instead of 1,000 requests, it will get 50 requests. Now, where does media CDN fit in? Media CDN, this layer, which is called POP cache, is 3 layers of cache. So first is the cache layer, which sits in the ISP, and the second is the cache layer, which sits in Google infrastructure. So let's say you have Airtel network at your home and you're watching a match. There's a very high possibility that the content you are about to watch is somewhere in the caching node of Google, which is placed inside Airtel's network. If that is the case, it will be served to you in no time. If let's say that content is brand new content and is not in the racks that we have in Airtel, it will be fetched from Google's own POP, which is also in India, by the way, right? And if it is not there also, then only we'll go and fetch the content from origin, right? So let's say if thousands of people start watching a popular content, maybe 90-95% get it from the ISP cache, another 2-3% people get it from the in-pop cache, only remaining 1% of the people, they directly go and fetch the content from the origin. So there is a shielding of cache which is happening in this architecture. I'll take a quick pause to see if there are questions on this section, and I then move to the last section.
We don't see any questions, Gaurav.
Alrighty, sure.
Yeah.
So I think I move on to the last section. Now you have connected, you have secured your network, you have scaled out. How do you manage your day in, day out operations in Google Cloud? Because the success of entire cloud journey would be how well you manage your environment in Google Cloud.
I think we just had a raised hand. So before you dive into the section 4, we have a question from Radhika. Radhika, I've allowed you to talk. Can you please unmute yourself and ask your query?
First of all, thank you, sir, for giving such a golden opportunity.
Yep.
My query is, in 2 CDN solutions, how we can manage and how we can give the security for large amount of data, and how we can rebuffering same amount of data for large amount of files.
Sure. So I think you are asking 2 questions. One is around rebuffering and second is around security.
Yeah, exactly, sir.
Yeah. In CDN environment, the typical security requirements fall under two buckets. First is secure the content. Second is secure the access. By secure the access, I means that only, again, the same example, only India users should be able to watch my cache.
Okay.
I'm streaming a match, and this match should only be visible to viewers in India, right? Let me take a different example. If you buy Netflix, the prices of Netflix in India versus prices in Netflix in US are different. If they don't bring in security, everybody will buy Netflix subscription in India and will start watching in US, right? Now, that is called geo protection, which means that when you sell a content in the country, you should be selling it only in the country where you have rights for. And that is called protection.
Sir, it means just like a public sector, right?
Sorry, what is that? Public?
It means just like a public sector. It means everyone can access, right?
Right. So this is called, technically this is called geo protection, which means that
Okay.
you want to protect by geography, that my
Uh,
content should only be visible in this geography.
uh, uh,
The second piece of the security is, how do you protect your content itself? By
uh.
content, I mean, you can either say www.example.com and your content should be visible, or you use something like a signed URL. By
Mm.
signed URL, I mean you have a token authentication kind of happening, wherein you say, and these are two different concepts, by the way. By token, you say that I'll give you a token. My website will give you a token, and that token will be validated only for 5 minutes. After 5 minutes, a new token will come, and then you will authenticate yourself, and that's how it works, right? Or
Okay.
you give me a signed URL. By signed URL, I mean www.example.com, question expiry is equal to this, valid equal to this, and those kind of big URLs which are difficult to copy. So these are two buckets wherein you do security in this. And for the buffering question, I think by
How
the
we
nature,
have to rebuffering the data. It means same amount of data we have. It means a large amount of data we have, but how we have to rebuffering the data? Is it for security purpose?
so by rebuffering, do you mean revalidate the data, as in the data is changing? Is that what you meant, or what is rebuffering in your question?
It means how we have to rebuffering the data.
Okay, so
For storing purpose, I am asking, sir.
So for storing, the data still remains stored into your buckets, as in your storage buckets like Google Cloud Storage or any other bucket where your data resides.
Mm-hmm.
The responsibility of CDN is just to fetch the data from bucket and deliver to the end users. That's it. That's the responsibility of CDN. CDN comes into delivery piece.
Only for deploying, or it means delivering of the data.
Yes, your
That
data
is the.
your data still resides in those buckets where it was. We are not changing your data.
So it means no one can hacking. It means no one can access the data, and there is no loss of data. Our data, it will be secure.
Yes. So data security is your responsibility, as in the customer responsibility, and we just fetch the data from that bucket and deliver it to the users.
For our responsibility for securing.
Yes.
Thank you, sir.
Okay. Now I'll move on to my last section, which is visibility. Now, visibility in cloud comes in every phase of your cloud journey. Let's say you have still not started your cloud journey. You will still have questions that, is Google Cloud the good cloud partner for me, which can give me the performance that I need. So for example, you want to check that my web will be in Mumbai and my database will be in US. How much millisecond will be the latency between Mumbai and US if I deploy my application on cloud? So you need some answers to that. Now let's say you decided to go with the cloud journey and you are in a migration phase. You want to kind of find answers to questions like, where should I deploy my resource? Um, what is the best practices? Which resource is talking to other resource? Let's say you cross that phase also, you are in steady state, which is day 2 operations. You want to find out the root cause of what happened. Your application went down. Why it went down? Was it an application error, or was it a database error, or was it a network error, right? And you want to stay compliant to network and security benchmarks that you have laid down. And last but not the least is the optimization. Can you optimize your security? Can you optimize your cost? So the visibility piece remains with you no matter which phase of cloud journey you are in. You can be a beginner, or you can be an intermediate, or you can be a 4-year, 5-year-old person in cloud, but you need to have visibility as your best friend when you are operating in the cloud, right? Now, anything which is related to network visibility falls under a common term in GCP, which is called Network Intelligence Center, NIC. NIC, think of it like a Swiss Army knife. It has various modules under it, right? I'm going to talk about only these 4 modules as of now because these are more network related, and this is in context of what I have talked in last 1 hour with you. The first is called network topology. The second is performance dashboard, then the connectivity test, and then the firewall insights. Now, what is the network topology? Network topology is a tool that gives you visualization of how your network inside of Google Cloud looks like. Let's say you have 100 VMs, 5 load balancers, VPNs connected to your on-premise, dedicated or partner interconnect connected with your data center, AWS connected using VPN. Now you want to visualize how my network looks like. How much traffic is coming from load balancer? How much traffic is going from VM to internet? My traffic is looking this today. How was it yesterday, etc. So to answer all those questions, network topology is your answer. Like you see on the graph, this gives you visualization, and this is not a static visualization. It is a live thing that is happening in your Google Cloud. It changes every minute basis how your network is changing in your Google Cloud, right? So for example, right now you have 5 machines. It shows 5 machines, how much traffic is coming into those 5 machines and how much traffic is going out of those 5 machines. Where is the traffic coming from? Is it coming from India? Is it coming from China? Is it coming from Russia? Is it coming from Singapore? Is it coming from UK? It tells you everything, how much traffic is coming in, how much traffic is going out. Now, what is the use case of that is one, which is network topology. Now, the second tool that I want to introduce is called performance dashboard. Anything which has to do with performance. And performance, I mean latency and packet loss. Anything which has to do with performance comes under performance dashboard. For example, you want to find out how much is the performance between Mumbai and Singapore. So if I place my web VM in Mumbai and database in Singapore, and these two wants to talk to each other, how much latency should I expect? How much is the packet loss for last 24 hours? All those performance related things, performance dashboard is the place to go, where it can show you how much is the latency, packet loss, not just now but for historical period of last 6 weeks. Now, third tool that I want to introduce is called connectivity test. Now, what is a connectivity test? Sometimes your connectivity is broken between source and destination. Let's say you are pinging from your one VM to other VM, the ping is broken, it is not working. Now, there can be n number of reasons for that. Connectivity test is a tool which will show you step by step where your traffic started from and where is it failing. For example, in this diagram, it started from VM, it went to GCP Cloud Firewall. Green means it was allowed to go through. Then went to routing table of GCP where there was no route available. It just says the subnet route is not available, and that's why it is red. And that's where packet could not be dropped or could be dropped. It says that you please go and check here, somebody deleted the route. So it is more a visualization of how traffic is moving. Let me take another example. A traffic coming from internet, it came to my load balancer. Load balancer was supposed to deliver that traffic to VM, but it dropped the traffic. Now, why dropped the traffic? It says health check failed, which means there were 3 VMs, 0 out of 3 were healthy. That is why load balancer could not deliver the traffic. So you please don't troubleshoot on load balancer. Please don't troubleshoot on anything, but just troubleshoot on this fact, why this traffic got dropped. And this gives you an easy and faster remediation of the problem. Last is firewall insights. Firewall insights, as you know, firewalls are complex to manage. As you write 10 rules, 15 rules, 20 rules, the rules keep on growing, and that is where your difficulty in manage also starts, right? If you use tool called Firewall Insight, it gives you enough insights into what is happening in firewall. For example, there can be a allow rule which is not even in use. So why are you allowing this rule? Or there can be a deny rule on which lot of traffic is coming and getting denied. So have you by mistake written that deny rule, or is it actually a deny? So it will keep on giving you all those insights. For example, allow rule with no hit and deny rule with lot of hits. It will give you these statistics, like in last 1 day, how much request has come. And then comes the concept of shadow rules. Like you have written 2 rules and one is overshadowing other rule. So either you delete that second rule or you kind of adjust that first rule so that it does not shadow the second rule. So all those insights are given by Firewall Insights. The message that I want to leave you with is, when it comes to anything which is related to network visibility, you should remember one term which is called Network Intelligence Center. Under Network Intelligence Center, and it is commonly known as NIC. Under NIC, there are various modules. For example, network topology. For example, connectivity test, performance dashboard, firewall insights. These are your friends when you are stuck at something not working and you want to find out why is it not working. Generally, people say till yesterday it was working, today it stopped working. So till yesterday it was working, go back and check 24 hours back, how was my topology, how is my topology today, and compare. Or connectivity test, when it was run yesterday, these were the results. When it runs today, here are the results. Where is it failing? What has changed? Right? So these should be your friends in the time of issues, and that is where it helps you in running a streamlined operations. I think I'm done with my presentation. I'll take pause to see if there are any last minute questions.
Great. Thank you, Gaurav. That was tremendous as a session, and I know you've covered and packed in a lot within time. So I really hope this webinar was beneficial to the participants. We just have one raised hand, a couple of raised hands now. So I will allow Palla Vamsi Krishna to talk. Maybe you can ask, unmute yourself and ask a query. Palla, if you're able to hear us, please unmute yourself and ask your question. Let's move on to Hemant. Hemant, I am allowing you to talk. Please ask your question, unmuting yourself.
Hello.
Yes, Hemant, we can hear you. Go ahead.
No, sir, there is no questions to me.
Okay, no problem. Thank you. All right, so I think we are at the end of the session. So just for the benefit of everybody, the recording of this session will be available on the FutureSkills Prime YouTube channel. So if you go to the YouTube page and you search for FutureSkills Prime, you will get to our channel and you will see the recording of this webinar posted over there. This will also be handy to you in the closing email, which should reach out tomorrow to your registered email addresses. I want to reiterate and tell everyone that when you complete these courses as NASSCOM, we have developed assessment for this particular program. And this assessment is available for the nominal fee of 600 rupees. So you can take this assessment, also get a nationally recognized certification. This is something that adds tremendous value to CVs as well as to your job applications. Also, when you clear the NASSCOM assessment, we have some exciting gifts available for the top 200 learners passing this assessment. As we are on time, if you come up with any questions while you are doing this course, I would request you to write to our support email addresses. So there are two support email addresses that we generally use. The first one is support@futureskillsprime.in. You can mention the course name and send in your query. We'll get an answer to your email. The second, if it's specific to the Google Cloud course, you can write to support@quicklabs. So that's support@qwiklabs.com. And again, specific to that particular course, the Google Cloud team will be happy to get that question answered for you. Just to recap, the recording will be available, and this was probably the last session for the APSCHE cohort, and we request you to complete the course surely by the end of August. Also, ensure to appear for the SSC NASSCOM assessments, as we have some exciting gifts available for the top 200 learners who have passed this assessment. So with that, I would take a leave, and I thank you all for participating. I hope this session was very enlightening for you. All the best.
Thank you, team, and thank you, Akash, for arranging this.
Thank you. Thank you, Raghavendra. Thank you, Gaurav. Thank you, Asha and Shweta.
Thank you so much. Thank you, Gaurav.
Thanks. Bye-bye.
Thank you. Bye.
Bye.